This is the second section of our third chapter for triangles. We are going to look at similar triangles. First, let's define what similar means. Similar, according to Google, is resembling without being identical. And it's really important that we emphasize that it's without being identical. Your revisions book defines two similar triangles as triangles whose corresponding angles are congruent and whose corresponding sides are proportional in length. So you need to understand the difference between congruent, and we're going to talk about what proportionality is. But two similar triangles are not entirely congruent, exactly the same. Proportional, what does it mean when two things, polygons or objects, are proportional? In math, a proportion consists of two equal ratios, usually written as a fraction. So here's an example. We have a fraction or a ratio, a over b, and it's equal to c over d. That tells us that they are proportional. Why? Both of these fractions need to be equal to the same decimal. You know how in your work you like to change your fractions to decimals? Well, if two fractions have the same decimal, then they are proportional. For example, here we have two different fractions. We have 0.3 over 0.4, and that's equal to 1.5 over 2. They're two different fractions. But if we divide them and we change them into a decimal, we'll notice that they're both equal to 0.75. Therefore, these two fractions, although different, they are proportional because they have the same decimal. What does this have to do with triangles? Well, we've looked at congruent triangles, and that tells us when they are exactly the same. Sometimes triangles are not exactly the same, but they can be similar. And similar triangles have to do with proportionality. So proportions are important when proving if two triangles are similar. So congruent triangles had cardinal rules, 3 of them. We looked at them all, SSS, SAS, ASA. But similar triangles also have rules like congruency. Some are the same, but they're applied differently. Our first cardinal rule for similarity is called angle-angle, or AA, which says that two triangles that have congruent corresponding angles, are similar. So if two triangles have two of the same angles corresponding to each other, then these triangles are similar. So here are two triangles. We have ABC and DEF, and I give you their angles. We write this as, like the hypotheses, angle A is equal to angle D. We see it, they're 85, and angle B corresponds to angle E, and they are the same, they're equal to 33. So therefore, triangle ABC is similar to triangle DEF. And I just want to point out a few different symbols here. Angle A is equal to angle D, not with the little squiggly line, because it's not equal and congruent to, it's just equal to. We see that angle A is equal to angle D, they're equal to 85, same with B and E. The next thing I want to point out is this squiggly line here. We're not talking about congruency anymore, we're talking about similarity. This little squiggly line tells us that ABC is similar to DEF. Here are our two triangles again. These two triangles do not have the same side lengths. You can see they're kind of weird shaped. They're not the same side. However, they do have these two corresponding angles which are congruent, and because two corresponding angles are congruent, it makes them similar. Our second rule of similarity is exactly like the rule that we had in congruency, only a little bit different. Side angle side. When two triangles that have one congruent angle, so the angle has to be the same, contained between corresponding sides that are proportional in length, are similar. So angles need to be exactly the same, but the sides that are beside this angle are just proportional, not the same. It differs from congruent triangles when the sides are of equal length. You need to recall what proportional means. Here are two right-angled triangles. What do you think about these two triangles? Well, they're both right. One is bigger than the other. Do you think that they're similar? Here they are again, except this time I label them with side lengths. Now, just looking at it, are the side lengths the same? No. We have 3.8, and its corresponding side here is 1.9. And we have 2, and its corresponding side length here is 1. But they're bounded by the same angle, a right angle, 90 degrees. Even though we know that they're not the same, are these corresponding side lengths proportional? Here they are again. So remember, corresponding sides. So in this case, our corresponding side, AC, its corresponding side is EF. So if they're proportional, the top to the bottom of this one and the top to the bottom of the other one should be equal to 2. So in this case, 3.8 divided by 1.9 is equal to 2. Are the other sides proportional to it? Well, yes it is, because 2 divides with 1 and we get 2. Therefore, because these corresponding sides equal to the same number when we divide them, they are proportional. We also have that angle C is equal to angle E, which is 90 degrees. It was given to us. And therefore, triangle ABC and DEF are similar by side, angle, side. And remember, the sides are not equal. They are proportional. Our third cardinal rule of similarity is side, 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 which is similar to the congruent one that we have seen. But in this case, the side lengths are not exactly the same. They are proportional. Congruent triangles have side, side, side when they are equal in length. Similarity, proportional in length. So here's an example. Here are two triangles. Again, what do you think about these two triangles? They look the same, but one is bigger than the other for sure. Here they are again, but I give you some measurements in this case. Now, it's helpful to try and identify what the corresponding sides are first. So DE here corresponds to AB, and EF corresponds to BC, and AC corresponds to DF. So now we know which proportions we have to check are the same. Now, in order for side, side, side to be true in similar triangles, each corresponding side's proportion needs to be equal to all the other sides' proportions. So let's check this out. Are the sides proportional? Our first corresponding side is the base, so AC and DF. If we do 8 divided by 3.2, we get 2.5. So now if we were to do the same thing with all the other corresponding sides and they're all equal to 2.5, they are proportional. Otherwise, they are not proportional, so side, side, side doesn't work. If we get this other side, AB, and we corresponded to DE, we get 4.5 over 1.8, and we get the same proportion, 2.5. So okay, we're on the right track. We already have two proportional sides. Now the last one, BC and EF, 5 over 2, also gives us 2.5. So we have the same proportion for each of the corresponding sides. Thus, triangle ABC is similar to DEF by side, 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 because each of the corresponding angles share the same proportion. A helpful fact for SSS is if you have two corresponding sides of the two triangles are proportional, you can find the third side using that proportion. So here are two triangles, ABC and DEF. I give you 12 and 42, so these two sides are corresponding. The base here, 9 and 31.5, are also corresponding. Now, if these all have the same proportion, we could figure out what AB is given DE. So let's try it. Here are the two triangles. So if the known corresponding sides are proportional, so the known corresponding sides being AC, DF, CB, and EF, you can use this to find the missing side length. So AC corresponds to DF, which gives us the proportion of approximately 2.9. BC is corresponding to EF, and we get, again, a proportion of 0.29. Therefore, to find AB here, we use this DE and the proportions and cross multiply. BC over EF, which is 2.9, is equal to 12 over 42, which is AC over DF, which is equal to some measure AB over its measure corresponding side, 52.5. And if we cross multiply, we get that measure AB is equal to 15. So if you do 52.5 times 12 divided by 42, or if you do 52.5 times 9 divided by 31.5, it doesn't matter. You still get that measure AB is equal to 15 centimeters. So just to recap, triangles are similar if angle, angle, two triangles that have two congruent corresponding angles, so the angles need to be the same and they have to be the corresponding angles. Remember what corresponding angles means. The second rule, side angle side, two triangles that have one congruent angle, so the angle needs to be exactly the same. However, the contained side lengths only need to be proportional. They don't need to be of equal length. And finally, side, side, side is when two triangles are congruent if their corresponding sides are not necessarily equal in length, but are proportional, so they have the same ratio. This is the end of section 3.2 on similar triangles. Next up, we will look at metric relations in triangles, and that will be the last section of this chapter 3 on isometric triangles.